Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Our today's topic is for class 12th, that's field intensity at a point on the axial line of dipole. In the previous lectures, we have discussed about electric field, electric field intensity, electric lines of force, properties of electric lines of force, electric dipole moment, and today we want to discuss or we want to derive the expression or we want to calculate the electric field intensity at a point on the axial line of dipole. Here we want to calculate the electric field intensity which is created by an electric dipole, and we choose a position on the axial line of the dipole. Why we want to find the electric field intensity or due to an electric dipole? So in this case, we consider an electric dipole which consists of two charges, one is positive and another is negative, which are separated by the distance, that's 2L. Let O be the center of the dipole. Now from the center of dipole to the positive charge length is L, and from the center of the dipole to the negative charge length is also L. The overall length between the two charges, that is 2L. Now P be the point on the axial line where we want to find the electric field intensity due to an electric dipole. But what is the formula which we use here to calculate or to find the electric field intensity at this point due to an electric dipole? So we have a formula that is the that we have already discussed, electric field intensity at a point due to a single point charge, which we made by using Coulomb's law. Now, so first of all, electric field, the electric field intensity at point P due to an electric dipole. So we will calculate it. First of all, we will calculate electric field intensity at point P due to the positive charge and then due to the negative charge. So we'll write here. Field intensity, electric field intensity, at a point P due to plus Q charge, So that will be written in this way: E1 is equal to, according to that formula, that is 1 divided by 4 pi epsilon naught Q divided by R square. Now R square is here. R square. No, electric field is created by the positive charge. So we have to take the distance from this plus Q to point P. But all the distance are measured from the center of the dipole. So this portion, we will neglect this portion. So that means the distance from positive charge to point P. So this will be x but minus L. So it will be x minus L. So we'll write here x minus L whole square. So this is equation first. And the direction of this field, that is towards this. This is the direction of the field. So direction of electric field, that is towards this. This is the direction of the electric field. Now similarly, we will find the field intensity at point P due to the negative charge. So we'll write here field intensity at point P due to negative charge, means minus Q charge. Here it's minus Q charge, it's plus Q charge, minus Q charge. That we will written in this way: E2 is equal to, similarly, so this formula, this we have already calculated in the previous lectures, 1 divided by 4 pi epsilon naught Q divided by. So here the distance, so electric field is created by this negative charge. So but the point P lies at this, on the axial line. So that means distance will be from the center to this point and from the center to this. So this will be equal to x plus L. Here the distance will be x plus L. So we can write here x plus L whole square. So this is equation second. हम इस तरह भी लिख सकते हैं यहाँ पर. So the electric field is created by the negative charge. So we'll write here minus. It's created by the minus charge. Now the total electric field. What is the total electric field? So the total electric field will be the sum of the two. The total electric field, the net electric field, net electric field, net electric field, net electric field is equal to. So we'll write it as net electric field, or we'll write it as E. That is equal to. So E1 plus E2. E1 plus E2. Now, as far as the vector addition is concerned, we must reduce one from another, because we have, so this has the larger electric field and this has a smaller electric field. This is created by the positive charge and this is created by the negative charge. So जैसे आप यहाँ पर देखेंगे, the electric field created by the positive charge, that इसकी डायरेक्शन जो है वो यहाँ की तरफ है, that is towards this. But the electric field created by the negative charge, जो इसकी डायरेक्शन है, that is towards this. So they are opposite to each other. They are opposite to each other. So similarly, the total electric field will be, we must reduce one from another. One from another. So that means, so we will reduce this, we will reduce this from this, because here is the larger electric field, the denominator is smaller, so here is the minus sign, and it's the larger electric field. Here the denominator is, here the sign is positive, so the denominator is larger, so the electric field will be smaller. So we can write here E, electric field E is equal to, so 1 divided by 4 pi epsilon naught Q divided by x minus L whole square plus, अब यहाँ पर minus, so it will be minus 1 divided by 4 pi epsilon naught Q divided by x plus L whole square, x plus L whole square. Okay, E will be equal to total electric field intensity at this point due to an electric dipole. So here 1 divided by 4 pi epsilon naught, 1 divided by 4 pi epsilon naught, it's common. Q is also common. We'll write here Q divided by 4 pi epsilon naught into 1 divided by, this will be x minus L whole square, minus times, here it's minus 1 divided by x plus L whole square, x plus L whole square. Or we can write a total electric field that is equal to Q divided by 4 pi epsilon naught into, so we'll cross multiply here, we can write x plus L whole square minus times x minus L whole square whole divided by. So here it's x minus L, it's x plus L. So this will be x square minus L square. We have a plus b into a minus b. So we'll write here whole square. This is whole square. Okay. So this will be or electric field is equal to. So here it is Q divided by 4 pi epsilon naught int. So we solve here. We have to solve this. This will be x square plus 2xl plus L square minus times. Here it's minus times x square minus twice xl plus L square whole divided by x square minus L square whole square. जैसे आप यहां पर अगर देखेंगे, so this will be प्लस एक्स स्क्वायर माइनस एक्स स्क्वायर कैंसिल हो जाएंगे, प्लस एल स्क्वायर माइनस एक्स स्क्वायर एल स्क्वायर ये भी कैंसिल हो जाएंगे. सो और टोटल इलेक्ट्रिक फील्ड E is equal to Q divided by 4 pi epsilon naught into. So 2xl, this will be minus into minus plus 2xl, so it will be 4xl divided by x square minus L square whole square. whole square. Or we can write here E is equal to, that is equal to Q. Q divided by 4 pi epsilon naught int. So this is 4xl. So 4xl, so we'll write it as 2l into 2x divided by x square plus x square minus times l square whole square. So we know that हमने ऑलरेडी पढ़ा है डाइपोल मोमेंट. सो डाइपोल मोमेंट हमने डिफाइन किया है. डाइपोल मोमेंट इज द प्रोडक्ट ऑफ, दैट्स डिनोटेड बाय P, that is the product of either charge, that means Q, either charge plus or minus, either charge plus Q or minus Q, and the separation between the two charges, that's 2L. Separation between the two charges, that's 2L. So we'll adopt this quantity here. Dipole moment E is equal to, so this electric field intensity at point P due to an electric dipole, that will be, this will be here, it is of P into 2x whole divided by 4 pi epsilon naught into x square minus l square whole square. So this is the exact relation for the electric field intensity at point P due to an electric dipole. But we want to make some approximations here. If the dipole is very small, since the dipoles are very small, if the dipole is very small, dipole is very small, so if the dipole is very small, then this distance, this length L, it can be neglected as compared to the distance from the center of the dipole to the point P. So if the dipole is very small, then we can write here dipole is very small, that means L is far less than this x. So we can write here, then if dipole is very small, then L, if 2L, we write here, if 2L is far less than this x, then L can be neglected. We will neglect this and L can be neglected. Therefore, we can write here electric field intensity E, that is equal to, so we write here dipole moment P into 2x divided by 4 pi epsilon naught into x square. So we neglect this L square, x square whole square, or total electric field intensity, that is dipole moment P into 2x whole divided by 4 pi epsilon naught. This will be x raised to power 4. So x और x cancel होगा यहाँ पर. We'll write here or total electric field intensity E, that is equal to, that will be equal to twice dipole moment, the magnitude of dipole moment divided by 4 pi epsilon naught x raised to power 4. Or we can write in this way, total electric field intensity, that is equal to 1 divided by 4 pi epsilon naught. So this 1 divided by 4 pi epsilon naught, it is the constant for the medium, into twice magnitude of P strength divided by x raised to power. So here it will be x raised to power 3. X raised to power 3. So this is the total electric field, net electric field intensity at point P due to an electric dipole. So it says, it means that it shows here the electric field is not zero here. It has some value. So now let us see here what will be the direction of the electric field. Here the direction of electric field direction created by the positive, the electric field created by the positive charge, that is towards this. That is towards this. This is the electric field. As well as direction of the electric field created by the negative charge, that is towards this. But the total electric field, that will be along this. So that will be along this will be the electric field. Direction of the electric field. Similarly, we also know that the direction of the dipole moment, that is from negative charge towards the positive charge. So we can say here the direction of the electric field, the net electric field, as well as the direction of the dipole moment, that's along the same direction. So I hope you will like this video.